we're going to move on to section 9.5, but before we move on to section 9.5, which is all about the quadratic formula, we need to remember how to simplify square roots. Okay, so today's a little mini lesson, a review lesson on simplifying square roots. So it'd be nice if you took out a piece of paper and jotted some notes down, especially if you don't remember it. If you do remember it, then I guess you could relax and just follow along here. So first of all, you need to know what a perfect square number is and how to make a perfect square number list. If you go 1 times itself, it's 1. 2 squared is 4, right? 3 squared is 9, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and so on and so on. So you should be able to come up with this perfect square number list on your own. I don't have it memorized. I don't expect you guys to have it memorized. Just 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. You could come up with this list. Now these are perfect square numbers. So the square root of a perfect square number is a perfect answer, right? What do I mean by that? Whenever you see a square root, what it's really asking you is what number times itself will give you that answer 49. So the square root of 49 is what? 7. All right. I'll do it in blue. How about the square root of 81? 9, right? Again, the square root is just asking you what number times itself gives you this answer 81. 9 times itself gives you 81. How about the square root of 25? 5, because 5 squared is 25, right? I hope you guys understand that. What's the square root of 9?
3.
What's the square root of 100?
10.
Square root of 36?
6.
Square root of 81?
9.
Oh, we already did that one. Yeah, okay. So as you could see, taking the square root of any of these perfect square numbers is a nice, beautiful, perfect answer. Now, but what if I said, what's the square root of 20? Well, square root of 20 is not a perfect square number, so you're in between the 16 and the 25. So it's one thing to give like a decimal approximation. Like you could say that the square root of 20 is roughly about 4.5, 4.5. Because the square root of 16 is 4, the square root of 25 is 5, and 20 is pretty much in between 16 and 25. So your answer would be approximately 4.5. However, we don't want decimal approximations. I mean, sometimes I do, but not on this section. On this section, I want you to simplify it. And the idea is that if you don't have a perfect square number inside your square root, rewrite it with multiplication to get a perfect square number. All right, so I'm going to move this out of the way. And think about 20. You could rewrite it with multiplication. It would be pointless to rewrite it as 2 times 10. Why? Because 2 is not a perfect square number and 10 is not a perfect square number. So how do you want to rewrite 20 as? 5 and 4, but you want the perfect square number first. So it'd be good to write it as 4 times 5. And back when we studied square roots, we learned that you could split the square root if you're multiplying. So we're going to put the square root on the 4, the square root on the 5. And this is why we want the perfect square number first. The square root of 4 is a nice perfect answer too. And the square root of 5 is going to stay the square root of 5. So there's your simplified form, 2 square root of 5. Could somebody get a calculator? And does anybody have a calculator? Do the square root of 20 and read me that decimal. Yeah, that is correct. The square root of 20 with the calculator is 4.472135955, and it continues forever. It's an irrational number. So obviously, you don't want to write a decimal number that continues forever. That's why we just leave it in simplified form with the square root. So that's if you did the square root of 20. If you did with the calculator 2 times the square root of 5, it's going to give you that same crazy decimal. But we're going to leave it as square roots, right? We're not going to write them as decimals. How about this next one? The square root of 125. It's not a perfect square number, but I could rewrite it with multiplication as what? Should I rewrite it as 5 times 21 or 25? 5, actually, yeah. 25 first and 5 second. So the idea is you want a perfect square number. And if you think about 25, is it divisible by 4? No. Is it divisible by 9? No. Is it divisible by 16? No. 125 is divisible by 25. there are 5 quarters in $1.25. So I would rewrite this as the perfect square number 25 times 5, and then I would split the root, and then you could actually do the square root of 25, which is 5. Then you bring down the square root of 5 and you leave it. Are you with me? How about the square root of 72? If you guys have a calculator, do me a favor. Try to do 72 divided by 4. Yeah, 72 divided by 4. Will it work? It's 18, right? So one option is to rewrite it as 4 times 18 because 4 is a perfect square number, right? But that's not the best. Yeah, you want the highest perfect square number. That's good. You guys remember that from when we learned this a month or so ago, or even longer, I think. But yeah, you want your highest perfect square number. So don't go with the first one, 4 times 18. Try 9. 9 times something give you 72? Yeah, 9 times 8 gives you 72. Sure. 36 times 2. That's the highest perfect square number that you could use. That's great. That's awesome. Let's use that. We're going to rewrite this as 36 times 2. And then you split that root, and you'll get 6 square root of 2. Sound good? All righty. What if, let me move this out of the way, all this stuff out of the way. What if we had the square root of, let's say, 22. Square root of 22. Could I mean, first of all, 22 is not a perfect square number. No. Could I rewrite it with multiplication to get one of these perfect square numbers? 4 times 11 is 44. No. 4 times 3, no. Can't. You can't, right? So we just leave it like that. If I ask you to simplify, you just rewrite it. There's nothing to do there. Okay? Make sense? Same thing with like the square root of 13. You just leave it, square root of 13. Square root of 7 stays square root of 7. Bless you. So you guys get the idea, right? Okay. So you always want to think about rewriting it with multiplication to get a perfect square number. But if you can't do it, then it's already simplified. Bless you again. Let's move on to the next topic or on this review lesson. You can't do what? It's not that you can't. You could do the square root of a negative, but you just won't end up with a real answer. It's going to be an imaginary answer, okay? So the square root of a negative number is imaginary. And specifically, here's the big fact that the square root of -1, that actually produces the variable I, which means imaginary. It's not real, okay? So if you don't feel comfortable with that, please write that down right now. The square root of a negative number is imaginary. The square root of -1 is I. Now, there's many ways of thinking of this. I always look at it and take this minus sign and just move it out and put it as an I. So what I really have is I times the square root of 9, which is really just going to be I times 3 because the square root of 9 is 3, which is really 3I. So your answer to the square root of -9 is 3I. In reality, I'm never going to... Okay, yeah. For -25, the square root of -25 is 5I. So right here, I would recommend taking that minus sign, moving it out, becomes I. So you really have I times the square root of 20. And then the square root of 20, it's not a perfect square number, but you're going to rewrite it with multiplication to get a perfect square number. So are we going to rewrite 20 as 2 times 10? 4 and 5. 2 is not a perfect square. 10 is not a perfect square. That doesn't work. 4 and 5, 4 is a perfect square. So you, and bring down the I. Don't forget about the I. So when you split the root, you got the square root of 4, the square root of 5. The square root of 4 is 2, and you still need to multiply that by I. And you have the square root of 5 at the end. So your final answer will be 2I square root of 5. 2I square root of 5. I times 2 is like x times 2. That would be 2x, but in this case, 2I. And whenever you have a square root, write that square root at the very end. What do you guys think?
It's a lot of math, but it seems something easy.
I mean, it's a review Bless you. You should all know how to do it, but I know we're kind of rusty on this, so that's why I reviewed this. Bless you again, a lot of allergies. The main idea is if you don't have a perfect square number, you want to use the highest perfect square number when you're breaking it down with multiplication. Make sense? The highest perfect square number. So like if I said, let me think of one. Move this out of the way. But right here we're involving I, which, what the heck happened there? Sorry. So like let's say I had, how about the square root of negative 98? So first of all, that negative sign comes out as what? I. Comes out as I. Okay? So I really have I times square root of 98. And 98 is not a perfect square number. So the question is, could I rewrite that with multiplication to get a perfect square number? So if you don't have your list, just write it out. Make a list. 1, 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and so on and so on. So of these numbers, how could I rewrite 98 as these numbers? Which one?
49 times 2.
49 times 2, exactly. 49 times 2 is 98. So you would rewrite that as 49 times 2, split the root, bring down the I. So you really have I times square root of 49 is 7, and the square root of 2 will stay the square root of 2. So your final answer that you would type in is 7I square root of 2. I hope this makes sense. And I say type in because for the rest of the class, we're going to work on a quizzes assignment that's on Google Classroom that's just on this review of simplifying square roots, okay? Some of them will have negatives, which means imaginary values come out.
It says error, the request could not. Oh, never mind.
Yeah.
So anyway, that's what we're doing for the rest of the class. Please feel free to help each other. Raise your hand. I'll help you out. This is just a review, just on square roots, and it is a homework assignment, right? So it is going to go into your grade.
Last time?